Hello bananas and sledgehammers, my name is Joseph Moore and we are doing some construction over on the kitchen right now. Well, I am. Me and my dad. Look at that, we got some real wall tearing outage going on right there. So yeah, if you just follow me, we'll be making my way to my room. Oh, wait. I forgot. You don't want to get off of your lazy butt, so alright, Jessica's gotta carry you with me. Alright. Okay, so we're back and all situated, and well, you guys might have heard that a couple weeks ago down at the LHC in Geneva, Switzerland. The folks at CERN have confirmed the Higgs boson! So yeah, they found the Higgs boson, and they see that it has a mass between 125 and 127 giga-electron volts. Electron volts are a unit of energy, much like BTUs, joules, or calories, only an electron volt is much smaller. Giga-electron volts, however, have a pretty sizable magnitude. And you could measure mass in electron volts because of Einstein's special relativity formula, E equals mc squared, where there is a conversion factor between mass and energy. In this case, it's more handy to represent the mass of the Higgs boson in terms of electron volts. So the Higgs has been discovered, or confirmed at least. Does this mean that the world of physics has been rocked on its side? Well, no, not really exactly. The Higgs boson is actually a part of the standard model of physics, which was been theorized for about 50 years now. A group of scientists in the 1960s, including Peter Higgs, whom the Higgs boson is named after, got together one day and theorized about a particle that gave everything in the universe its mass, and that's basically what the Higgs boson does and why it's so important in the universe. What I'm going to do right now is give you an intuition about the Higgs boson that you might not have right now, so let's get cracking. Before we understand what the Higgs boson is, let's first understand what mass is, okay? What's mass? Mass is the resistance of an object to change its position or its velocity that it's traveling at. So for example, that means an object with less mass, let's say a baseball, is easier to stop than an object with greater mass, say a bowling ball traveling at you at 30 miles per hour. Okay, now we know what mass is, but why do particles need something that causes them to have mass when they don't need to do so when they have charge, right? Well, actually, charge and mass are pretty different concepts, especially on the particle size scale. Every charge is quantized, which means evenly divided by an integer by the electronic charge. Mass has no such constant quantization. In fact, mass changes depending on the velocity that you're traveling. Einstein theorized that as you approach the speed of light, you get heavier and heavier. The energy that you put in goes to your mass, so it gets harder and harder to accelerate a little more and a little more faster, which is why the speed of light is the constant in the universe. Okay, so let's get to the question. Why do neutrons have more mass than protons, which have more mass than electrons, which have far more mass than photons, which are massless themselves? Well, the answer is the Higgs field. All throughout the universe, you can imagine just this field that's completely uniform in all directions. So you can think of this field as kind of a net throughout the universe, and particles like the proton and neutron interact with this net a lot. They kind of get tangled up, and that's why it's hard to move them, whereas particles like the photon don't interact with the net at all, and they're allowed to go whizzing around the universe at the speed of light. So, if the Higgs field weren't there, that means that every single particle in the universe would be traveling at the speed of light. It's roughly 300 million kilometers per second, which is, frankly, a little too fast for me. So, yeah. Thank the Higgs that you're here right now. See you next week. Bye. Hey guys, sorry about that awkward splice in time. I'm walking right now instead of in my room, but I actually am heading over to my mom's to edit the video that I just made that you just finished watching. I'd just like to say, yes, I do know that today is a Monday, that I have uploaded this video on a Monday, and rest assured next week will be a punishment video. And you'll see, it's going to be a little different than the other punishment videos that I've done.